Hi children, this is the fifth video of the topic differentiation. In this topic, I am going to discuss about the nature of the turning point. Before we discuss about the nature of a turning point, we have to understand what do you mean by a increasing or a decreasing function. If you are talking about an increasing function, we can understand that when you increase the independent variable, that means x variable for example, the dependent variable also increases with that. That means when you increase the x variable, the y variable also increases according to that. From these examples, you can understand that throughout these three examples, when the x value or the independent variable increases, your y value, your dependent variable also increases. When we discuss about the decreasing function is the opposite of the increasing function. That means when independent variable or x variable increases, the dependent variable or y variable decreases with that. From these three examples, you can understand that throughout the way, when independent variable or x value increases, the y value decreases with that. That is the simplest idea about a decreasing function. If you refer our previous videos about differentiation, I hope you are having a very good idea about positive gradients and negative gradients. If you refer to the diagrams of positive gradient graphs, you can simply understand that all of the graphs having a positive gradient. We know that gradient of a graph is explained by its first differentiation. Therefore, if a particular graph is having a positive gradient means they must have a positive value for first differentiation. From these simple combinations, we can understand that if a graph is increasing, we can simply say its first differentiation answers must be a positive value. Same way, if you refer to the graphs with decreasing function, you can simply understand that all of the graphs are having a negative gradient. That means the first differentiation or dy by dx must be a negative value if the function is decreasing. Let's try to verify this theory from first example. The question is y equals to x squared plus 2x minus 12. We need to find the value of x where the function is increasing. We know that the concept where we know about increasing function is its first differentiation must be greater than 0. Therefore, first of all, let's try to find out the first differentiation of x squared plus 2x minus 12. If you differentiate once, you will receive the answer 2x plus 2. That means since the function is increasing, dy by dx is greater than 0, therefore 2x plus 2 should be greater than 0. If you simplify this inequality, you can simply understand that x must be greater than minus 1. Therefore, the range of the function x squared plus 2x minus 12 is increasing at x values greater than minus 1. From this diagram itself, we can make sure with this theory. So if you draw the diagram relative for x squared plus 2x minus 12, you can understand that the function increases after minus 1. Before minus 1, function is decreasing, it's coming down. After minus 1 only, the function starts to move up. That is the range where the function is increasing. Hope you can understand this theory clearly from this diagram. Let's come back to example number 2. In this question, they ask us to find out the increasing range for the function for y equals to x cubed plus x squared minus 5x plus 1. From the previous theory itself, we can understand that if the function is increasing, its dy by dx must be greater than 0. Initially, let's try to find out the first differentiation of the function x cubed plus x squared minus 5x plus 1. If you differentiate the function, you will receive the value 3x squared plus 2x minus 5. If you are having a doubt about how to do this differentiation, refer to our first videos. Then you can factorize this quadratic function. You may need to do this factorization because when you are finding this inequality, this factorization format is really essential. Then we know that if the function is increasing, its dy by dx must be greater than 0. Therefore, 3x plus 5 into x minus 1 should be greater than 0. If you solve this quadratic inequality, you will get the answers x is less than minus 5 over 3 or x is greater than 1. Therefore, if you plot this graph y equals to x cube plus x squared minus 5x plus 1, you can really understand that before minus 5 over 3, the graph is increasing. Up to minus 5 over 3, the graph is increasing. Then from minus 5 over 3 to 1, you can see the function is decreasing. It's going down. Again, after 1 only, you can see that function is increasing. Therefore, we can verify this theory from this diagram itself. Before minus 5 over 3 or x is less than minus 5 over 3, function is increasing. After 1, that means x is greater than 1, function is increasing again. Hope you can understand this theory clearly from this diagram. In example 3, they expect us to find the decreasing range of the function x squared plus 4x minus 12. So we will follow up the same proceedings. Initially, I will try to find out dy by dx. If you differentiate it, you get the answer x squared plus 4. Therefore, we know that if a function is decreasing, its first differentiation must be less than 0. Therefore, 2x plus 4, the first differentiation must be less than 0. That means if you simplify this inequality, you will receive the answer x is less than minus 2. If you draw the graph of y equals to x squared plus 4x minus 12, you can understand that up to minus 2, the function is decreasing. The function is coming down up to minus 2. After minus 2, only function is going up. Therefore, the function is decreasing up to minus 2. That means x is less than minus 2. Example 4, they ask us to find out the decreasing range for the function y equals to x cubed minus 2x squared minus 7x plus 1. So as the initial steps, we will differentiate the function y equals to x cubed minus 2x squared minus 7x plus 1. Then if you differentiate it, you get the answer 3x squared minus 4x minus 7. Then I will factorize it and keep it because this factorizing format is essential for us to simplify the inequality. Then we know that if the function is decreasing, dy by dx is less than 0. That means 3x minus 7 into x plus 1 should be less than 0. Then if you simplify this inequality, you receive the answer x is less than 7 over 3 or x is greater than minus 1. From this diagram of the graph where y equals to x cubed minus 2x squared minus 7x plus 1, you can simply understand that up to minus 1, the function is increasing. That means function is going up. From minus 1 to 7 over 3, the function is moving down. That means that is a range where you need to obtain a negative value for dy by dx. That means that is a range of function is decreasing. After 7 over 3, again function is moving up. That means function is increasing. Therefore, this inequality verifies from this diagram as well. X is greater than minus 1, more than minus 1 and less than 7 over 3. X is less than 7 over 3. Only you can understand that function is decreasing. Hopefully you have understood the concept which I want to discuss from this topic, and hopefully you have enjoyed this video. Please put a thumbs up and subscribe my channel. Thank you.